memorize this formula very well. Q over CF or M over capital M IT over CF. Question number 1. What mass of gold is deposited during electrolysis of gold 3 tetraoxosulfate 6 when a current of 15 ampere is passed for 193 seconds? Here we are told specifically what mass of gold. So we don't know mass of gold. Okay? But we know the molar mass of gold is given there 97. Is given what? 97. We know time is given there 193 seconds. We know, what do we know again? We know gold. We know the charge of gold. What charge does gold carry? But here, are we going to say it's 1? Look at it.
Theory.
Theory. So it's not 1. So you are caught. Silver carry that many charge?
1.
It carry 1. Thank you. So gold here carry 3. So we are going to look at that. And then we're also told of what? What were we told? Ampere, current, 15 ampere. So using this formula, we are looking for mass. You make mass subject to formula N equal this over IT CF. M therefore is this over. Let's bring it down. What's molar mass? 97. What's current? 15. What's time? 1 there what? 93 over 2 Faraday, 96,500 coulombs. You do everything for me and tell me the answer quickly. How does 0.97 grams. So from what we have here, the answer is 0.975. 97 grams. Okay. So that's the answer. The answer is 0.9. Okay, 0.97 gram. Thank you. That's what we have. So that's the answer to question number 1. Okay, our students, we continue. We're done with question 1. Question 2 is such a standard question. It says when a current of 1.25 ampere passes through acidified water for 9.8 minutes, full stop. Find the volume of oxygen released at this and this. And then we are given some parameters there. The first thing you do to this question is to write the equation of reaction. Very important. And so let's check out what's happening. We know that to release oxygen, this is usually the reaction, and then 4 electrons are liberated. Those electrons actually is what you call like Farad or Faraday. 1 electron is like 1 Faraday. 4 electrons refer to note of what I am doing. Very important. Okay, so from here now, let's now find the quantity, which is current times time. Quickly check out for me. Okay, let's continue do that. Yeah, let's go ahead. There's no problem. So read the question now. What are the parameters we are given? The current is given to us. Look at it here. The time, is it given? Where is it? It's given. We convert it. So we have 1.25 times 9.8 times 60. Okay, so we have this. Multiply that.
735.
735.
735.
735 coulomb. Now, what is this telling you actually? It's telling you that in equation of reaction, we have that 4 mole of the hydroxy releases what? How many farads? 4 Faraday. Are you getting me now? So it releases 4 Faraday. So it is like saying that, listen very well now, it's like you are saying that this one release this. How many will Faraday with this one release? So you're making a comparison of what this is going to release. But because we are solving question in volume, for 1 Faraday it is 96,000 ahead. Then for 1 mole, now this is 4 mole to release 4 Faradays here. Now watch what is happening. Now for the 4 Faraday that was released, which is 4 times 90, talking of in terms of volume, it gives you the molar volume of the gas. That's the molar volume of the gas, which is 22.4 dm3. That is 1 mole of every substance at STP gives you what? 22.4 dm3. So if this is what we have, how many will 7 this? 7 what? 5. I mean C. How many volume will it give us? If 4 times it gives us this, want to know how many this will give us. So we quickly do that, and then, well, what are we going to have now? So we're going to have 735 times 22.4 over 4 times 9650. So let's see what we are going to have quickly. Please go ahead. 0.6. Please make sure you're sure what you're calling. 0. You're changing the what? Here we have 0. 0 point in DMQ. Is that taken, students?
Yes, sir.
Yes, sir. So we have gotten this now. The next thing is, the question says we should do something. So find the volume of oxygen released at this final temperature and final pressure. This is initial volume. So it's the final volume they are asking us to find. And we have to use our general gas law. So how do they normally do it? P1, or let's say V1, right? V1, P1 over T1. Can you remember this SS1 thing? How many of you can still remember this? So we're looking for V2. V2 becomes this. So let's see the parameters we are given now. So V2 not known. V1 we have got to it. So we take it to DMQ, to CMQ, which is what? Multiply by 1000. What do you have? 0.6. It's 42. So P1.
1.01.
We call that standard what? Pressure. Thank you. C1. At STP2, it will be a standard temperature since we have standard pressure here. What again? P2. What is left? T2. So we can compute the value now. So V1 is what?
42.
P1. Somebody is helping. T2.
298.
Oh, yeah, we're getting ready to punch.
273.
Then
273 times 0.5 to times 10 to the power of 5.
that's P2, I mean.
Yes, 0.5 to times 10 to the power of 5.
89 point what?
05.
05, which is, that is the
Answer.
volume of the oxygen released at that temperature and pressure respectively. Students, is there any question on this? Is it very clear? Okay, there's a question over there.
To get our V2, is there any like way we can use formula instead of that?
Is there no way we can use
Formula to get that V, to get in that V1?
to get V1
Yes,
that we did the other time?
Yes,
Is there no way we can use it? No. Our formula does not cover that aspect. You have to solve it in that regard. So follow this pattern. Thank you. Any other question? Okay, so for our students online, if you're not clear with what I've just done now, or you are wondering what I did, systematically follow everything I've said. If you're not still clear, you are at liberty to ask questions. Will be explained better to you. And in case you're also wanting to join my community, where I'm building up young scholars, I'm building up people who will become a pace setter in their various field of endeavor, then you might have to show your interest also in the comment section, and I'd like to add you to the platform, to my community platform. Thank you very much, and God bless you. Bye.